So we looked at a bunch of students that studied between 0 and 5 hours, and that matters mostly for question 7, the 0 and 5. Found the following relationship, so y hat is negative 2x plus 10. So first of all is interpret r squared, and this is that one you just basically have to memorize. So that's 80% of the variation in the data, and it's almost always a multiple choice, so you usually can just recognize the phrasing. You sometimes don't even have to memorize it. It can be explained by R least squared regression line. So remember, this is called the least squared regression line. Find and interpret R. So this is where I'm not trying to trick you, but it could have thrown some people off. So how do you go from R squared to R? Is square root, right? But there are two square roots. There's positive and negative 0.89. And then you got to decide which one. So you're going to use the negative one in this case, which we usually don't. And there's two reasons. You can think of it two ways. One is just there's a negative sign. The slope is negative. So you can just look at the negative slope and be like, okay, it's a negative R. But also, like, why is it a negative R? And that might help some people understand. It's because the relationship between these two variables is inverse. It's opposite. Like, one goes up, the other one goes down. So as time you study goes up, what happens to the number of errors you make? It goes down. So that's opposite. That's inverse. That's a negative relationship. Positive would be like the more I study, the more errors I make, which doesn't make any sense. Then interpret it. I would say strong, negative. Do I know right now if it's linear? I do not. Relationship, but what else do I still need? Need context, so I'd say between hours and errors or something like that. Studying and errors is probably a little better. Alright, find and interpret the residual for someone that studied 2 hours and made 7 errors. So the residual is y minus y hat. So y is 7. Like I'm telling you, that actually happened. This person actually made 7 errors. How do I find y hat? Plug 2 into the original equation, which gives me 6. So my residual is 1. So to interpret that, what would I say? Good. So 1 more error than predicted. How do I know it's more? Because it's positive. If it was negative, we made less errors than we predicted. So that's like the above the line, below the line thing, like I've got drawn up there. Find the number of errors. So now we're going a little bit backwards. So the residual equals y minus y hat. But I'm telling you the residual is negative 4. And I'm looking for the number of errors. So I'm looking for the actual. And then I can find y hat by plugging in. So if I plug in 3, I get 4. And then if I add 4 to both sides, I'll actually get 0. How many had 0 there? Good. Questions on the first 4, let's say. Just stop there. Alright, if I include a point 3, 20. So it would help here to look up at this graph, I think. If you have an idea of what the graph looks like, you can kind of picture where 3, 20 is. If you don't, so 3, 20 is going to be way up here. But the way I know that is if I plug in 3 here, what would I expect y to be? I'd expect it to be 4, right? So if this is 3, this is the point 3, 4. Well, I said 3, 20. Which is all the way up there. So is that an outlier in the x direction or the y direction? The y direction. So when I look at the line will barely move. So there would not be a significant change in the slope. There would not be a significant change in the y-intercept. Correlation is tricky. Would the relationship get stronger or weaker? Weaker, because it's more spread out, right? It's not as compact as it used to be. Well, if it gets weaker, that doesn't mean necessarily it gets smaller. It gets closer to 0. So because we're negative, if I get closer to 0, is that increasing or decreasing? It's actually increasing. So I'm going to use this. I'm not sure if this is like school appropriate or not. I really have no idea if I get in trouble for this. But like R equals negative 1 is way over here, right? That is strong AF. R equals 1. Strong AF. R equals 0. Weak AF. So we're here at R equals negative 0.89. Like, is that still appropriate? If I get, like, I have no idea if I get in trouble.
Well, I mean, you talked about drugs the first day of school, so I think this is fine.
I didn't cuss, though. I guess I'm not cussing here. I don't know. It doesn't matter.
You're just saying letters.
Yeah. Strong as friend.
Yeah.
So, if I weaken the relationship, it goes back towards 0. Isn't that increasing it, though?
Yeah.
Because we're below 0, weakening it would increase it. If I were above 0, weakening it decrease. So just be careful with the negative. It throws off the way you normally think about things. So this would not, and then this would actually increase. The relationship gets weaker, but R actually increases. All right, now I do 20 comma 3. So 20 comma 3, well, if I plugged 20 in, I'd expect to get negative 30, so I'm like way down here. I'm putting it up here, 20 comma 3, so it's kind of like there. So if I have this point, is this an influential point now?
Yes.
Yes. Is it a high leverage point?
Yes.
Yeah, that's the same thing, right? So that's going to tilt everything toward it. So your new line would be, probably going to tilt more than I just did, but it would tilt up. So your slope would increase, which means your y-intercept would. Remember, my elbow is the y-intercept, so if the slope goes up, my y-intercept goes down. So the slope would increase, the y-intercept would decrease. And that's still a point that's really far away from all the others. So my relationship would get stronger or weaker? Weaker, because I'm spreading the data out. But in this case, is that increasing or decreasing R? It would be increasing, because we're going more towards 0. Remember, correlation is R. Questions on 5 or 6? And then 7, so we studied people that, or we looked at people that studied for between 0 and 5 hours. Now I'm saying, could I use this to determine what happened for someone that's like 12 hours? Well, I've got a bunch of data here between like 0 and 5, and it kind of makes, something like this. Is it safe for me to assume that pattern continues way over there at 12? It's not. And actually, if you plug in 12, you end up with like a negative number of errors, which I don't even know what that would be. But that's called extrapolation. You should not do that. So no, it's outside of our data, or it's extrapolation. So there's this thing on the AP test. They do not make you memorize vocabulary words. If you can like explain the word, you don't have to use it. So if you remember extrapolation, just write no, that'd be extrapolation. If you don't remember that word, just say no, that would be like assuming the pattern continues. Like you can describe the word instead of using the word. Any other questions on QC? Questions on this page at all? I've got another one for you. And tomorrow we'll do frappies. Next day we'll review. Test on Friday. Start working here. The goal is not for you to have homework. The goal is for you to finish this, check it over before you leave, and get squared away. I'll put up the answers as you go. Hopefully you finish your questions answered and move on tomorrow. If I can help you, let me know. That's the point. That's why we do it in class.